Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about interpolation, in which Newton's backward interpolation formula we are going to discuss. This lecture includes definition of interpolation, backward differences, and Newton's backward interpolation formula for equal intervals, and we are going to solve a problem using Newton's forward interpolation formula. First, definition of interpolation. The definition of interpolation, according to the mathematician Thiele, it is defined as the art of reading between the lines of the table. And the second point is the process of computing the value of the function, that is, the value of f of x at the point x within the range, that is, within the given data of our problem, which is interpolating, that is the value what to be found, which is interpolating within the given data of our problem. That is why it is called interpolation. So you can see here, to find the value of y corresponding to every value of x in the range, that is within the range. That is why that is the interpolation. If it lies outside the range, then it is called extrapolation. Now we will construct backward difference table. Here we are taking the points x0, x1, x2, x3 and x4, y0, y1, y2, y3 and y4. That is, here at the point x0, the value of y is y0. Next, at the point x1, the value of y is y1. Next, at the point x2, the value of y is y2. At x3, it is y3. At x4, it is y4. The differences. How the differences? You can see this arrow mark, y1 minus y0. Here it is written. Next, difference between y2 and y1. So y2 minus y1. Next, y3 minus y2. The difference is written. y4 minus y3. Next we have taken. You can see here the operator, that is invert delta. It is called del, that is backward difference operator. We will call it as del. Now this first column, this is first backward difference. Now how we have our own name, that is everyone used to call us keeping our name. The same way, the first now, the difference, y1 minus y0, the name we have to give that difference between y1 and y0. So the name is del y1. The next, the difference between, that is this y2 and y1, that is y2 minus y1, the name we are giving del y2. Next, y3 minus y2, the name we are giving del y3. Next, y4 minus y3, the name is del y4. We completed first backward difference. Now, we will move to second backward difference. That is the difference between del y2 and del y1. So the difference is here. Del y2 minus del y1. Next, the difference between del y3 and del y2. Next, del y4 and del y3. So the differences that it is listed here. The operator is backward difference operator. For this table, this column is second backward difference. For that operator is del square. Now the difference naming we can see it here. That is del y2 minus del y1. It's nothing but del square y2. Coming to the next one, del y3 minus del y2, it's nothing but del square y3. The last one, del y4 minus del y3, it's nothing but del square y4. We completed second backward difference. Now we will march towards the third backward difference. So the difference del square y3 minus del square y2, here it is written. The next one is del square y4 minus del square y3. It is written here. So this column, the operator is del cube, because this is the third backward difference. So we will use here del cube. Now the naming part, del cube y3 for this difference. That is del square y3 minus del square y2. So the name is del cube y3. Next, the same way, del square y4 minus del square y3 equal to del cube y4. We completed third backward difference. The next, fourth backward difference. The difference del cube y4 minus del cube y3. The operator is del power 4. The name is del power 4 y4. Yeah, we constructed this backward difference table. Yes, to construct this, we have taken x0 from x0 to x4. That is 5 points we have taken, and we constructed the backward difference table we constructed. Fine. In mathematics, to keep the names, formulas, what is the easy way we have to search? So the easy way, it is there. We can see it now. So you can see. So this animation part, 4 circles are there. The first circle, that is the difference, it is there, y1 minus y0. In that, y1 is circled. The next one, y2 minus y1, first that y2 is circled. So all these 4 the differences, the first one is circled. So y1 along with this operator del, it is becoming the name of the difference del y1. Next, y2 with this del, it is becoming del y2. y3 with this del, it is becoming del y3. y4 with this del, it is becoming del y4. So similarly, the next one also, y2 del square. del square y2, y3 del square y3, y4 del square y4. The next y3 along with this del cube, it is del cube y3. y4 del cube, it is del cube y4. So y4 del power 4, it's nothing but del power 4 y4. So from this, the circles which indicates, that is how to keep this formula, the naming part, in a very easy manner in our mind. That is the first, along with this, that backward difference operator we are naming. To construct this backward difference table, we have taken 5 points. That is x0 to x4 we have taken. But it is only to construct 5 points are taken. But what about the last term? We know it, the last one, it's mathematically nth term. So the nth backward difference formula is, we can see here, del power n yr equal to del power n minus 1 yr minus del power n minus 1 y r minus 1, where r is taking the value from 1 onwards, that is 1 to so on. So now we can put n equal to 1 and r equal to 1 in the above formula. So wherever n we are going to substitute 1 and r we are going to substitute 1. So we can see here. So n, it is taking the value 1, r it is taking the value 1. Here 1 minus 1, so it is written here, r is 1. Next 1 minus 1, here it is written. Here also 1 minus 1, it is written. Yeah, correct. So next we can see it. So del power 1 minus 1, 0. Del power 0, y1. Here it is not written this del power 0 because we know it mathematically, that is according to exponential law, a power 0, the value is 1. That is the reason actually here 1 into y1 we didn't write. Next here minus del power here also 0. That is according to exponential law, a power 0, the value is 1. So y 1 minus 1, it's nothing but y not, y 0. So you can see here the one lengthy and the arrow mark. So it starts, that is y1 minus y0. We constructed the table, the y1 minus y0, it's nothing but del y1. We constructed that. Now using the formula also we got it, y1 minus y0 equal to del y1. So we cross-checked with our nth difference, that is the nth backward difference formula, with our table, it is correct. Even students can cross-check. Here also all the terms it will be coming. Next we will move. So we can see here Newton's backward interpolation formula. It's a very lengthy formula, it is there. But every mathematics, even a lengthy formula also, definitely to keep in the memory, to our memory space, definitely an easy technique will be there. That if we are catching, we never forget the formulas, even whatever the length is, so many terms is there also, we can write it. Now we can see this Newton's backward interpolation formula. The formula which is given by Newton, backward, we are using the backward difference operator. Interpolation, that is the value what to be found at the point x, which is interpolating within our range. within our given data of our problem. That is why it is interpolation. So Newton's backward interpolation formula, this is for equal intervals. That is the equal intervals in the sense the difference of the x points will be equal or same. Now we will see the formula. Just I will read the formula so you can watch this one. F of x equal to yn. Yn in the sense the last term, yn. U plus u by 1 factorial yn, so del yn plus u into u plus 1 by 2 factorial del square yn plus u into u plus 1 into u plus 2 by 3 factorial del cube yn plus u into u plus 1 into u plus 2 into u plus 3 by 4 factorial del power 4 yn plus the next term. It is not written here, but we can say easily. So you can see here now this is there, u into u plus 1 completely it is written, plus 2 is added. Next everything it is written here, plus 3 is added. Next what we should do it, everything we should write it, then u plus 4 is added. Here 3 factorial, 4 factorial, next automatically 5 factorial into del power 5 yn plus so on. The last term is u into u plus 1 into u plus 2 so on u plus n minus 1 by n factorial del power n yn. So this is the Newton's backward interpolation formula, where this u, the value to find x minus xn by h. Yeah, the same formula it is written. So already the previous slide I for equal intervals I told, I gave the explanation also already. So now this slide which helps us this animation part, you can see it here. Yes, 5 circles are there. That is the easy way how to remember. This is my own way to remember the formula to keep in, because so many formulas will be there, but while writing we have to cross check it. This technique is there, we can cross check the formula, what it is entered in your mind, what we are writing in the exam also correct or not, we can check it. The first term u not there, second one u is there, u into u plus 1, next u into u plus 1, plus 2 is added, everything is written, plus 3 is added, so on u plus n minus 1. Next you can see the some terms are rectangled. Yes, this rectangled part, so the first one is yn, the next del yn, del square yn, del cube yn, del power 4 yn, the last one is del power n yn. Now you can see this one, if it is del power 1 we are writing 1 factorial, if it is del square then we are writing 2 factorial, if it is del cube then we are writing 3 factorial, if it is 4 we are writing 4 factorial, if it is n we have to write automatically n factorial. Now more we can see, if it is del square, if it is 2, 1 less we are writing 1, if it is 3, 1 less we are writing 2, if it is a 4, so 1 less, automatically we should stop up to 3. So the last one is n, 1 less means n minus 1. That is the reason here it is written n minus 1. That is the explanation. Now So you can understand. So n1 less is n minus 1, where u equal to x minus xn by h. What is this x? This x is nothing but, in the given problem, that is in our given question, what is at what point at x the value of f of x will be asked. So the x that is written, xn, it's nothing but under x the end point is taken. Maybe our given problem 5 datas are there, so the last fifth one will become xn. Then here we will write x. Got it? According to that, x4 will be written. Now divided by h. Divided by h. Here I told 5 points means because starting we are taking as x naught. So x1, x2, x3, x4 will become divided by h. H is nothing but the difference between x points. Now we will take one problem. So that is here the years are given. The years starting from 1891, 1901, 1911, 1921 and 1931. The population, that is, it is given in thousands. So we have to first understand the question. We have to understand very clearly what is given in the question, what they are asking us to do. So at 1891, in the year 1891, the population is 46, and in the year 1901 it is 66, 1911 it is 81, 1921 it is 93, whereas 1931 it is 101. They are asking in the year 1925, what about the population? See, this 1925, where it lies between this 1921 and 1931. Between here it lies. That is the end of our data it lies. That is the one of the reason we are using Newton's backward interpolation formula. So if you are seeing this slide, Newton's forward, that word also it is there. Suppose if the question is 1895 it is asked, then it lies here, then we will use it here. Newton's forward we will use it. If it lies end, we will use it. Newton's backward we are going to use. We will construct Newton's backward interpolation formula. So we are constructing the Newton's backward interpolation formula. So x, under which we are writing 1891, 1901, 1911, 1921, 1931. Next, under y we are writing 46, 66, 81, 93. The last one is 101. Now we are going to give, this is 1891. We are naming, that is the initial point we are taking as x naught. The next 1901 we are naming as x1, 1911 x2, 1921 x3, 1931 as x4. Next 46, it is named as y0. Next 66, it is named as y1. 81, it is named as y2. 93, it is named as y3. 101, it is named as y4. So 5 points are there, that from x0 to x4 the names are given. Now how to read mathematically this? that is at the point x naught, that is 1891, the value of y naught is 46. Next, at the point x1, the value of, that is the value of x1, that is 1901, is y1 66. At x2, that is 1911, the value of y2 is 81. Similarly, the value of y3 is 93 at x3 1921. So the value of y4 is 101 at x point, that is x4 1931. So the problem, the given data of our given problem, it is listed under x, y, and all the data are also given names. Okay. Now this operator, we know it, Newton's backward difference operator. Difference we are doing. So we know it, 66 minus 46, the 20 is written. Next, 81 minus 66, it is written 15. 93 minus 81, it is written 12. 101 minus 93, it is written 8. So you can see this arrow marks. That is this red, the two small arrow marks, which indicates that how this 8 is obtained here. That is the difference between 101 and 93. This is to make our understanding level more. That purpose this the red arrow marks are given here. So we completed the first backward difference table. Next, del square, that is the second backward difference. 15 minus 20, 12 minus 15, 8 minus 12. You can see this, even the red, the arrow marks indicates how this 4 is written here. So 8 minus 12. Next, third backward difference, that is minus 3 minus of minus 5. The students, they have to be very careful here. Minus 3 minus of minus 5, that is minus 3, it is becoming plus 5. Negative signs comes, we have to check it twice. We have to be very careful. So 2. So the next, these two differences, that is a minus 4 and minus 3, we got the difference, the value is minus 1. So we can see this same, the arrow marks. So minus 1, how it is written here. Next, the last column is del power 4. So minus 1, minus 2. So you can see it here, minus 3. So we completed the Newton's backward interpolation formula. Naming part we are seeing. This 8 is named as del y4. This is minus 4 is del square y4. Minus 1 del cube y4. Minus 3 is del power 4 y4. So you can, here y4 is written, everything, because our ending the table, the value is y4. Whereas if you are noticing the before the slide, the last term, it is a formula, the last term, that's what it is taken, yn. Complete the formula, yn, it played a role. Whereas here, according to our problem, the last is y4. So del y4, del square y4, del cube y4, del power 4 y4. Each column, the last data are taken. So this is our backward difference formula. So to substitute here, y4, value is available. Del y4, del square, del cube, del power 4. All the values are available. We can pick from the this constructed Newton's backward difference table. And one more thing, we stopped the formula also del power 4. We can stop up to here because our table also end with del power 4. We no need to write the next term. Where here completely all the values we know except this u. So u is nothing but x minus, actually according to the formula, x minus xn by h. But our xn is x4. So x minus x4 by h. So now we have to find the value of u, because all the values to substitute in the formula, everything we know it except this u. U is nothing but x minus x4 by h. X, it's nothing but our given question. What is the data? What is the value? That is in the year 1925, what is the value of population? That is the at x point. So 1925 and x4, that is the under x, the last data 1931. H is nothing but under x, the difference between the x points, that is 10. We did the, so you can see this more understanding. X is 1925, x4 1931, h is taken 10. We calculated the value is minus 0.6. We got it. All the values we substituted in the formula. So we got it. So now you can see 101. We wrote it. This calculation is nothing but minus 4.8. This calculation is 0.48. This calculation is 0.056. This calculation is 0.1008. So we got it 96.84. So approximately we can tell 97. Now, so in the year 1925, the population is 97. Using Newton's backward interpolation formula, we got it. That is f of 1925, it's nothing but 96.84, approximately 97. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.